Hello, everybody. You are here for a talk. It used to be called hexagonal architecture, and I renamed it to philosophical architecture. This is a change which, happily, is the subject of my talk, is change. So, who is this person? Has anybody ever seen any of my talks before? Anyone? Anyone? No? Maybe one, two? Great. No preconceptions. My name is David Dawson. I run a software consultancy in the UK. We do most of our work in Europe, so we occasionally come over here, which is why I'm here. So this is me. Those of you who have seen my talks, you might realize that I tend to run out of material at about 20 minutes. But don't panic. It's okay. It's fine. We have some of the famous Spring One speakers here. And what you will notice is when I run out of materials, they will begin to ask me questions to try and keep things going as long as possible. So we are in safe hands. It's fine. So I want to start with a question. What is architecture? This is a real question. It's not rhetorical. What do we think architecture is? Any brave people? Structure? Whatever the important stuff is. Good point. Architecture and design. Do we think they are the same thing? This is a trick question, I'm sorry. Maybe, no. Some people do. So what I think is that there are many, many designs. You will be writing your software. Every piece of software has its own design, completely unique. Architecture, though, we recognize there are only very few actual architectures that we think of. And so architecture and design are quite plainly very different things. But what are they? What's the nature of them? What's the nature of architecture versus design? Well, I'm going to tell you what I think. If you disagree, that's fine. That's your problem. So, Grails. Grails has an architecture. It's very explicit, and it's very good for what it does. It's not always obvious when people approach Grails that it actually has an architectural approach that it's pushing on you. But it's all through the design of the way the documentation is laid out, the way it's explained, and the actual conventions that it implements. This is a very specific architecture. And it's what I would call N-tier and data-centric. So what do I mean by that? So N-tier is we have controllers, services, domain classes. These all exist as separate tiers in the application that then communicate between them. Data-centric is where you have your domain classes being your kind of primary artifact in the system. They drive anything. They are the source of truth. When you write your application, often you will start with your domain classes. And so it is very data-centric in the way it approaches things. This sometimes has problems. So if any of you were at the Birds of a Feather session the other night, you may have heard me complaining about stateless services or kind of some aspects of Grails architecture. This is not to criticize the way that Grails does things. It's to say that it is not universally applicable, and you shouldn't just adopt the Grails architecture without thinking about it first. And there are other ways of doing things, and that's what I'm going to be showing you today. So we're going to start a new project, totally greenfield. Who likes greenfield? Microsoft. Yes. Well recognized. Greenfield is fun. We like greenfield because it's easy to get things done. As soon as you want to make a change in your system, you just make the change. You don't have to think about it. You just write the software. But I'll show you what tends to happen, or at least in my observation, what tends to happen. So we start our greenfield project. We have our tiers. Grails is an N-tier architecture, so that's what we're going to adopt. We have our web MVC layer, our service layer, our data layer. I did use the term domain class before. Can everyone see that? Data layer. I did use the term domain class before. I should just get my notes up. Yeah, there we go. I don't actually like that as a term. I think it's misleading. Grails domain classes are the database persistence classes. They allow you to do object mapping between your business logic and your database. The word domain is heavily overloaded. It means different things in different places. And I'm going to be using a different way of using the word domain. Sorry. So we have our greenfield project. It's lovely. We have our N-tier architecture. We know what we're doing. Let's crack on. First thing we do, we add some controllers, some services, some domain classes, persistence classes even. The world is fine. We've decided to make a change, and we've made it. This took all of like 1 second to do. It was amazing. We have our links. We add some more code. This still is quite manageable. You know, how many classes is that? Easy to fit in your head. Get to version 1.2, suddenly things start to get a little bit bigger. Still reasonable, but we start to see that there are random kind of connections between things that possibly we didn't expect to start with. Our service layer starts to become a little bit more complicated. Go to 1.3, and oh my goodness, things start to get very complicated. Your service layer is getting thicker and thicker and thicker. Add some views, and suddenly you'll notice something. Where is the source of truth in this system? In Grails architecture, it's the domain classes. Where are they actually used? From this diagram, you won't be able to tell. So you could say, well, we have a domain class, and actually, our user would be scattered everywhere. We have our point, I think I've called it, whatever it is. Again, that's scattered all over the system. Your source of truth is everywhere. It's not the domain class anymore. That's just some kind of way of describing identity. And this is where most systems will end up, given enough time. They will get very thick service layers. Their database classes will be used everywhere. And at this point, there probably won't be a 1.4. What you'll do is rewrite. And this will be termed legacy. But that's not, I don't see why that has to be the case. So the issues that I see in this particular kind of architecture, there's all this coupling between the tiers. Now, you think that's natural. I don't. I think it's highly unnatural for your web layer to have a very deep knowledge of your database. I don't think that's right. Your service layer is supposed to be in the middle, and it's doing too many jobs. It's trying to service the web layer and the database layer at the same time. You have natural pieces of the system that should be vertical slices, and they just don't exist because in Grails, there is no concept of that. You just have these horizontal slices across your application. And so you end up with very, very tight coupling between your web and database through your service layer. That leads to what I call service spaghetti, and it's horrible. You end up with services that are being called by things you have no idea about, and you become afraid to change them. And this is where many systems end up, and it's horrible. I've written too many systems like that for me to do it again. I don't want to be there, and I'm sure you don't either. Another thing that I see that is a flaw, well, I wouldn't say flaw in the Grails architecture, but it's explicit in what it does. It actually directly exposes your user to your data model. If you use the Grails scaffolding as at all, then your users know what your database layout is. And I think that is potentially dangerous, no idea. However, it does mean that your users know the database layout, which means you can't change it easily. You're locking your system together based on what the user expects. And I find this very hard to deal with because I want to change my data model at will to optimize things. I want to say, well, you know what, we're not going to use Oracle now, we're going to use React or Mongo or anything. We need to change things as we have kind of get different pressures on our systems. So our green field, unfortunately, is now this. This is the same place. It is no longer green. I did find out where it was. Maybe someone can know. But this is the same Microsoft XP, Windows XP field, and it is no longer the green meadow. And this is where our systems end up, given enough time. And I'm not happy with that. I don't think that we should be content with that as a state of affairs. And I would like to discuss, if you want to put it that way, although it will be me doing all the talking, how you might handle change in your system so that you don't end up with constantly generating legacy code. As an aside, software is the only place where legacy is a bad thing. Isn't that weird? So, architecture. The Grails architecture is data-centric and n-tier. So I'll go back to my original question. What is architecture? It's obviously led us to the place where we are with Grails. It's imposed, well, the Grails documentation and the way it approaches things has driven you in a particular direction. For many systems, that's fine, and it works well. For more complex systems that have lots of pressures coming in from different directions, it doesn't work quite as well. It starts to break down. But what is it actually that's driving you? Well, I would say that architecture is not the solution. That is your design. We've already come to the conclusion that design is separate from architecture, or at least I have. And so it is not the solution. Your architecture is the way that you approach the problem. It's the set of tools that you use to engage with the issue. It's the mental model that you apply to the problem at hand, to the domain. Now, I don't know about you, but this talk of mental tools to engage the world and to understand the problem, this sounds familiar. I've heard this somewhere else. And so I would put it to you that architecture actually is simply our word for philosophy. Philosophy is a set of tools for engaging the world, understanding it, reasoning about it, a process that you go through to make your decisions. And so for us, architecture is our philosophy, the philosophy of the system. So there's an interesting, I don't know what you call it, essay. Do you know a guy called Peter Nauer? Have you ever come across him? If you've ever done anything in something called BNF, Bacchus-Nauer form, which is often used for specifying computer language grammars, he's the N in that, a very clever chap. He wrote an essay in the mid-'80s called Programming as Theory Building, and it was speaking to this exact problem. He was saying that when you have a system, you have the code, but the code is not everything. You have your tests, but the test is not everything. If you have a new developer that joins the project, they have to learn a lot more than just the code layout. They have to learn a lot more than just the tests and the documentation. There is something else, which is, he called it the theory of the system. It's this piece of tacit knowledge on what the system is doing and why. And that has to be passed around between developers before they can cooperate in a really effective way. And this is what I would call the philosophy of the system. It's this tacit knowledge as to the reasoning why you are approaching things in the way that you are. So one question, what is your philosophy? Open to the audience. What do we think? Keep it simple. That's a good philosophy. So I've been since I came to this realization, I've been tracking through different philosophies and trying to figure out why we do things in the way that we do. And over time, I've started to notice something, and it's really quite unfortunate, which is this: perfection. Now, who thinks perfection is a good idea? Ooh, you're onto me already. So perfection is very interesting. And I think it has caused the world a huge amount of damage, the very concept of perfection. In software, this is causing us damage. Every time you write software, you are thinking perfection. In one way or another, it's influencing your thought. And I want to take you on a journey as to where perfection came from and why you think in the way that you do. Who knows this dude? That's Plato, or at least a rock that looked kind of like him. So he had this thing called the theory of ideal forms, or the theory of forms. And it's an interesting idea. So what he was saying is, you have certain aspects of the world that you can see, but how do I describe it? We have the world as we see it now. This isn't actually the reality. We're seeing merely a shadow of something else that is the true reality. We would call this the abstract. And as computer programmers, we're very happy with abstract being the real thing and concrete being just, well, that's just a representation. To give you an example, what's this? Not a trick question. It's a triangle. It is. This triangle has 3 sides, as all triangles do. I could draw something that looks very different, but you would still recognize it as a triangle. The reason is we have this concept of triangle, which is 3 sides put together. in Plato's theory of forms, he was saying that the form of the triangle is this concept of three sides put together. And that's the real thing. This is a shadow. This is not real. This is just some concrete bump. The real thing is the abstract. What about this one? It's a pony. Now, you can probably see where I'm going. This is a horse. This is, according to Plato, a shadow. We recognize this as a horse because we recognize the true form, the abstract form of horse, which has 4 legs, a tail, and a head. And so what he's creating is this kind of abstract idea. And this didn't exist before. People didn't think in this abstract way before Plato. And so this kind of set in the kind of Western thought, at least, the idea that there was something beyond the now, something beyond what we can see and touch and feel, and something beyond the concrete. There was this abstract ideal, this perfection. And what we see is merely a shadow of that perfection. Now, after Plato, a guy called Aristotle, who you may have heard of, came along, and he generated something called his category theory. And the way that he did this was to start to separate things out and identify this fits in this bucket, and this fits in this bucket, and this fits in this bucket. And so he took, for example, the horse, and he said, horse is a something. This is where we get reductionism from. So if you know what reductionism is, it's the idea that you can take something, take it apart, and understand it based on how you've taken it apart. So this modern scientific method is based on this. And he kind of took Plato's abstract ideas slightly further. So where did this actually lead us? This creation of the concept of perfection. This didn't exist before. This is new. Who knows what this is? Indiana Jones. What's behind him? Petra. Well done. This is Petra. This is a city in southern Jordan, or it was a city. Now it's just rock. And it looks beautiful. It looks very, very nice. So the history of Petra is that it was founded a long, long time ago. And what you see there is what's called rock-carved architecture, otherwise known as monolithic architecture. This is where you take a piece of rock and keep carving a single piece of rock and keep carving it until you get what you want. And all of Petra was monolithic. It was carved in a monolithic way, which is lovely. It looks very impressive. The history of Petra, however, is slightly less lovely. It lasted for several hundred years, and then there was an earthquake. And its aqueducts, that were also monolithic, cracked. And because they were carved out of a single piece of stone, they could not be repaired, and the city was abandoned. So this quest for perfection, I mean, that was perfect when it was made, but it wasn't real. It couldn't stand up to the reality of the changing world. When an earthquake came and broke the aqueducts, that was the end of the city. So where else did perfection take us? So kind of following our journey forward from Plato, we've gone through Petra, slightly more modern. Utopia. Utopia is a word that was coined, I actually forget by who, to describe a city, a perfect city, where everyone was organized to do what they would do best. And so this kind of has influenced our politics as well, this idea of perfection. And so we have this kind of perfect world that we're trying to achieve. And this isn't real either. We've seen kind of these utopian ideals, and we even use it as kind of a disparaging term now, utopian. But again, this is questing for perfection, and that's what we're trying to do constantly throughout history. Since Plato has created the concept, we're questing for perfection. Slightly closer to home. What's this? It's a waterfall. Now, sorry? It's just, yeah, it might be. It's a waterfall. So you may, as software developers, have heard of something called the waterfall development process. What else is this than a quest for perfection? We have the idea that if you plan something enough, you will get what you want. And that is, again, pretending that perfection exists. This is a slightly cheeky one. Don't hold this against me. Pure functional programming, this is very tongue-in-cheek. So a pure function has no side effects whatsoever. A perfect function has no side effects. If you do very pure and perfect functional programming, it will have no side effects whatsoever and, in fact, be completely useless. The only thing that you will see is that the computer warms up slightly when you're running the program. So all functional languages have some kind of side effect built in. They all disrupt their own perfection. Even if you go to something like Haskell, which is a lovely functional language, it is not pure in the sense that it does have side effects. It's just got very specific areas that it has them in. And so this concept of perfection, even in functional programming, has had to be dialed back because it's not real. Again, slightly tongue-in-cheek. SOA, service-oriented architectures. I remember SOA when it was first coming around. I'm sure many of you do as well. And it seemed like we were building a better world and that we were going to win and this was going to be it. And endless committees later, endless debate, endless specifications, WS star everything, and we haven't got a better world. This was utopian. This was a quest for perfection that wasn't real. And I just kind of look at all that and think, goodness me, this is horrible. This is a horrible world we're striving towards. You know, perfection has just destroyed us. So, what can we do? Are there any French people in the room? No? That's sad. So this dude, Voltaire, he's very well known for a particular saying, which is this one, le mieux est l'ennemi du bien. Translated, the perfect is the enemy of the good, or the best is the enemy of the good. And so he was recognizing a truth, which was we have this kind of perfection that we're striving for, and it's leading us to bypass all these valuable things. You know, we don't need perfection. It's complete lunacy to aim for perfection when we could just stop and say, well, you know what, this gives us what we need. We need to go no further. So, back in time a little bit, just to try and see what we can do about this. What wisdom from history could we use to counteract Plato and Aristotle, who were far cleverer than me? What can we actually do? So this is a time tunnel, by the way. Has anyone seen that? I haven't seen it in years. So this is a river. This is, in fact, the Tame River near where I live, in England, in northern England. It's called the Tame River because it doesn't really do anything. It just sits there and flows a little bit. And so you could say it doesn't particularly change. However, there was a guy called Heraclitus, again, another Greek. He lived before Plato. And he came up with the phrase, no man ever steps in the same river twice, which sounds silly. Until you actually think, well, looking at this river, yes, it doesn't appear to change. However, you can see it's flowing. The bank is slowly being eroded. It is actually in a constant state of change. When I put my foot in it, it is different water than if I put my foot in it 5 minutes later. It is different. There is always change. And this speaks to the truth. Perfection is not real. Change is. So another story. Have any of you ever come across this phrase, this too shall pass? It's awesome. So the story is, there are many versions of this story, but the story is there was a Persian ruler, modern-day Iran, and he was having trouble ruling, having trouble deciding what to do. He was getting either too much victory, too much defeat. It was hard. And so he sent his mystics away and said, give me some wisdom that is always true in every circumstance. And so they went away and thought about it for a long time, came back and gave him a ring. And it had this carved in it, this too shall pass. And this kind of, again, speaks to perfection is a fallacy. Everything dies, everything ends. Spring 1.2 GX will finish at the end of my talk. You know, that we know. I could keel over and go to sleep. Something is going to change. You know, we are going to stop our software development careers at some point. The JVM is going to be superseded at some point. Everything will change. Night will fall. And so we have a choice as to what we do. We can either attempt to carry on with our idea of perfection, or we can embrace change. We can say change does happen, and we need to make sure that we get the upside, so that when change does happen, we end up better. So perfection is a lie. You've been deluded by the Greeks. I'm very sorry. It wasn't me. Change is the only truth. And so we have to learn to embrace it. Now, how do we do this? Again, I'm going to dip into Greek philosophy. I hope you don't mind. So there was these guys called the Stoics. Have any of you ever heard of the Stoics? Awesome. So they're kind of founding, what do you call it? Saying? Sorry? Creed. Creed. Great word. So their founding creed is that destructive emotions result from errors in judgment. If you can kind of create in yourself a way that you can be happy, see the upside in everything, without kind of forces from outside controlling you, this is the Stoic philosophy, where you are in control of the way that you feel and the way that you act in any circumstance. And so you can kind of take advantage of change. You know that change is coming, and you can act in a way that is beneficial for you. However, Stoicism is slightly more complicated than that, as our Sean knows. So I'm going to give you a very quick primer. So there is again, a homily for the Stoics, which was sick and yet happy, in peril and yet happy, dying and yet happy, in exile and happy, in disgrace and happy. And this is speaking to, you know what, life is awful, but that doesn't mean that you have to be miserable. And so the Stoics have got a bit of a bad rep because they were seen as miseries, but they weren't. They were actually saying, well, in any circumstance, I control how I feel. Now, in software, we can apply this. We can say our software doesn't have to be beholden to the changes that are constantly churning around it. We can decide what changes that we want to affect our software and what changes we want to keep away. And this is kind of where I'm going with this extended tour through philosophy. Now, how do we actually do this? Well, there is one last philosophical tradition I want to expose you to, which is pragmatism. So pragmatism is actually homegrown in the US. It is a philosophical tradition that started around 1870, and it is my favorite philosophy in the entire world. It was started by a guy called John Dewey and Charles Peirce, and you could almost see it as the philosophical scientific method. Core tenets: reject dogma. Dogma is a lie. Dogma is where you have an opinion put upon you, and you aren't allowed to question it. And this is a horrible thing, especially for software developers, but it does happen constantly. So as an example, again, this is probably a trick question, who would consider themselves an agile software developer? Yep. Is that because of the tremendous amount of evidence? Because I haven't seen any. Not real evidence. It's what you do see is kind of quite anecdotal and with quite a lot of hearsay. There is no scientific proof that agile works. There is no scientific proof that it doesn't. I don't know. So I can't actually say you should do it or not. All I can say is maybe you need to look into it. Don't just accept what people tell you. So second tenet, gather proof. Understand what you are doing. Figure out the value of what your choices are going to be. Figure out the value of the two different choices you have and pick the one with the most value. Maybe agile software development is the way to go. I don't know. So change is real. In fact, it's the only reality. Now, you've been very patient. I need to show you some code. However, before I do, We need some kind of problem, some kind of something I can use to actually build some code to show you. I'm not going to build the code right now, by the way. I was doing that last night until 3 a.m. So we'll take some kind of business process, which is some kind of workflow, where we have some kind of document that comes in. We review the document maybe, someone approves the document or rejects it, and then inserts into some document management system. This is what I want to show you as an example. Now, what we're going to do is take this workflow, which is very simple and fairly standard, and apply all of the philosophy that I've just talked about at length to this, and see what happens to the code. Now, we saw some kind of general structure, some design at the start of this talk, and that was following the default Grails architecture, which is n-tier and data-centric. We need to build a new architecture. And to do that, we actually have to, following our pragmatic philosophy, figure out what the challenges are, gather evidence. So, what are the challenges? This is what I like to call the forces on the code. You can identify them if you think about it. Often they'll be kind of non-functional things, but sometimes they'll be functional as well. So, in our contrived example, we have a DBA who likes to play. He likes to constantly change what the database does. We have a user interface that needs updating very, very often. And the document system gets a new major version every 2 months. So this is quite a lot of churn. Yep, I'm getting to code, don't worry. Before we do that, we need to figure out where the change in our code base is going to be. And then, because we want to allow change to happen, we want to embrace change. We're not building the perfect system here. We're building a system that can be beaten around, that can accept the changes that's going on. So we need to create boundaries in between the different parts of the system to allow them to change relative to each other. So this kind of sets us up for a changing world. So we have something we call a life preserver approach, or diagram. And this is a diagram that lets you kind of almost have a conversation with the system, have a conversation with the change that's going on, and constantly be asking, well, this is changing in what way, and it's relative to what, which I'll show you. So we have our diagram here, and the idea is you have your core system, which you don't actually want to be affected by the outside world. This is the bit that makes you money, so you want to make sure it's perfect on purpose. Everything that's around it is the things that interact, the changes that are coming in from the outside world. And you want to make sure that they are not beating your core up. So we have our core domain. This is where you would put your business logic. Again, the code that makes you money. In our contrived example, we have a document workflow that I showed you before. That diagram will end up there. Because we have a DBA that fiddles and likes to change the database, we need to make sure that our document workflow is not tightly coupled to the database. This is very different to a Grails application. This is the primary difference, probably, because it means that the database cannot be our primary source of truth anymore. It's merely an integration. Again, we have our document system that changes. We don't want to tie too closely to this, so we've created another boundary that you can see. And so this document system will interact with the workflow, but it is not deep in our system. It's, again, another integration. We're going to have some kind of API, REST. Again, I've separated it out. You'll notice that the REST layer is nowhere near the database. We are not going to expose our database to the users. To do that would mean that our REST layer can't change, or our database layer can't change. In fact, neither of them can change particularly easily once you couple them together. For that reason, if you're ever kind of building any REST abstraction on top of, say, in Grails, it's very easy to just take a Grails domain class and put resource on it and turn it into a REST resource. I don't like that at all, because it means that your users have direct access to your database. And in any kind of larger system, that will start to cause you issues. Lastly, we have a user interface. The question, though, is we have our different domains, our different portions of the system. How do they communicate? That's a good question. I'm glad you asked. We're going to go with events. First question, though, what are events? When I say event, what do you think of? Sorry? Sorry, I didn't get that. Aha, good man. Does anyone think asynchronous? Yep, very good. Unfortunately not. I would put it to you that events are nothing to do with asynchronous behavior. They're nothing to do with messaging. They are instead, as we just heard, they're all about communication. They're all about saying that something has happened. It's changing the way that your application communicates internally. Broadly, it's from what you might call imperative to declarative. So instead of saying, you, code, go and do this, the communication changes to this has happened, as we just heard. And so kind of a little example. This would be imperative. So this would be a simple method call. Mr. Man on the left says, go and give me some milk, and man on the right, the callee, just says OK and gets the milk. Declarative is this, where we have some kind of event that's happened. I have used all the milk. And then the guy on the right infers the fact that more milk is now required. And so this is actually far richer. As far as communication goes, this is a much richer exchange. So we have our guy on the right. He can infer the fact that we need more milk, but he could then do anything else as well. This could be used. There could actually be many people on the right, many callees, that are all listening to the same declaration that I used all the milk, and go and do many other things. And so this is far more interesting in terms of internal communication in your system. This has nothing to do with asynchronous behavior. So the point of decision moves. So instead of the guy on the left deciding what to do, the guy on the right, the callee, decides what to do. And so as soon as you implement events, this is what happens. And this creates options. So if you want to respond to change, the key is always creating options for yourself. You have to figure out what potential changes might be coming in and give yourself some way out so that when the world does change, when a big earthquake comes and breaks all your aqueducts, you have some possibility of fixing them. Yeah, I really do need to show you some code. OK, so almost there. We're going to figure out how we're going to approach the problem now that we've decided to use events. So we're going to use a communication-centric, event-based architecture. It's domain-based. So the diagram I showed you before, each one of those is an application domain. It's an area of the system that moves at the same rate. And that's how I would generally classify a domain in this case. So each one of those, for example, the database, all the code in that section of the diagram generally churns at the same rate. And it will be a different rate to the user interface. And it is an architecture. I am not going to show you any frameworks. I am not a framework developer. That is not my job. And I really do need to show you some code. So if anyone wants to download it, if you can read that, it's there. It's on GitHub, my GitHub, David Dawson, and Philosophical Architecture. OK, so how are we doing? Not bad. We've broached the 20-minute mark. Still going. Let us set up the screens. OK, so we have our system. We need to make that a little bit smaller. OK? Yeah, that's good. Right. So this is a Grails application. I've implemented that diagram. I've implemented the workflow. What I would like to do is take you through this code. I'm not going to do live coding because I'm not showing any new framework. I'm showing you architectural ideas. You can get access to the code yourself, play with it, see what it can do. It's fairly, it's got slightly rough around the edges in places, but don't worry about that. So first off, we have our different domains in the system. Now, I said that there was boundaries between them. This is not using any eventing system. It's not using an event bus. It's not using any async behavior. We want to see these boundaries. So the way that those have been implemented in this case is as simple interfaces. So we have our workflow, you can see here. And this is the boundary. Can everyone see that okay? Yep, can everyone see that? It's kind of small. Does anyone know the key shortcut to boost size in IntelliJ? Oh. Okay. So what this is a just an interface. And you can see that the pattern of communication is declarative in nature. So we have our different actions that we can do against the boundary. You'll see that this is again, type checked. It's very tightly specified what's going in and out across this boundary. We have a set of events, which, again, they're declarative, so document saved, document submitted. Behind this boundary, we have our system workflow, our domain workflow. Outside of this boundary, we have whatever is calling it. And this is the point of communication. And this is eventing. Welcome to the new world. You could implement this using asynchronous behavior as well. And that might be good optimization. You could do it over messaging. That would be fine. It's the mode of communication that's important here. The other domains, so for example, we have our document system that we saw. Again, that is just a simple interface with very simple methods on it, but tightly specified. If you have any questions at this point, please just throw your hand up. Now we're through the philosophical spiel. Now, that's kind of low tech, really, isn't it? It's not terribly impressive. The real magic starts to come when you start to figure out what you can do behind these interfaces and what you can do around these boundaries. These boundaries kind of are very strong contracts in your system. You don't cross over them with any kind of state. Instead, it's all just events. With that in place, you can start to do some interesting things. So, for example, I'll show you the implementation of this workflow, which, again, is just a normal Grails service. And in fact, it's half implemented. The Renegade team that is supposed to be writing this decided they didn't want to finish it. And so we have several methods that are finished and several that aren't. So this is using an internal command pattern to implement the actual services themselves, the service methods. So we have our service facade that then delegates to these commands. These are just simple Spring components that do some business logic. It's not hugely different to what you might find in your own systems. Talking about forces on code, this code was originally written as part of a system, or it was it's very similar to a system that we wrote for a client. And the development team there is a broad range of experience. And so the code here is quite verbose. It's quite explicit in what it's doing. It doesn't use any groovy magic. You could almost write this in Java very easily. And that was done very deliberately because of the broad range of experience of the developers. We didn't want to make the code too dense. And so this, again, is potentially one of the forces that could be operating on your system, one of the forces of change. So with this in place, we have some of it implemented, some of it not. That's kind of cool, but we need a user interface. So let's go and have a look at the UI. I think this is now running. You'll notice that we have a save method working and a submit not. So let's have a look at. OK, so this is the actual application. Again, very simple, very straightforward. We propose a new document, and this goes to a controller, which I'll show you in a second, which is the UI domain. We save it. Hello world. This is a document. Great, that worked. Let's submit it. Boom, didn't work. So we have our user interface. We can't actually implement this until the workflow is finished. I think that's rubbish. I don't like that at all. What are we going to do at this point? Well, we actually have ready-made a solution for this, which is this boundary. This is the point of communication between the workflow and the user interface. We could replace what's behind it, and no one would notice. We've written our code, and I'll show you the user interface now. Here, so this is the code that we were just using. So if any of you kind of look me up on the internet, you will find that I deeply love command objects in Grails. They make me very, very excited. And this is the reason. What they do is they allow you to model HTTP requests very, very naturally. So here we have an HTTP request coming in on the propose method. That HTTP request naturally is several things. We have an identity, which is the URL. We have some state, which are the parameters coming in on the request. And then we have some expected behavior, which is the logic on the server side that should be executed. Now, when you have set those things together, where you have identity, state, and behavior, you're the one executing on those two, that is an object. And don't let the functional zealots tell you anything else. We can model this as an object. We can also model it in a functional style. By default, Grails models things in a procedural style, which is where you see this propose appearing. So what we're doing here is creating an OO abstraction around an HTTP request using a command object. We have our load document in here, and this is our nice OO modeling of a request. What this does is just take the parameter and create a new event and send it into the workflow. So you'll notice there's no state here. There's almost no expectation of state mutation. All you're expecting is that an event goes in and an event comes back. We have a communication going on. The actual decision on saving things is inside the workflow. It's behind the workflow boundary. Here, we don't see that choice at all. So we could replace that workflow with something that does something slightly different. The decision could be done in a different way. And the user interface wouldn't care. It wouldn't notice. And so that's what we've done. We actually have a second implementation of the workflow. So we have our workflow service here that does our stuff where this is broken. And those renegades that are supposed to be writing this service just aren't. And me as a UI developer, I want to get on. I want to write my functional tests. I want to implement stuff. And I'm held up by these people. And I don't like that at all. So what I'm going to do is remove their service. I'm going to, at runtime, replace it with something that can communicate in the same way. It doesn't have to manage the state in the same way. I don't care about the state. We've just seen that using this eventing style, state management has gone as far as the user interface is concerned. And so we can replace it with a stub that looks like this. So here, I've created a very simple service, if you can see, that implements the same contract. But instead of doing any kind of state management, all it does is record that an event has come in and then return some pre-canned data. So there's no there's no saving, there's no loading, there's no database at all. We have intercepted all these calls, and now we can control them, test them even. So I'll show you what happens when this goes on. So I actually have a controller that allows me to switch which service is actually being used, what's behind the boundary. And the way that I use that is via HTTP. Oops. OK, so in a new page, I'll go to localhost 8080, what's it called? Document, domain status. Right, so I have a controller. It tells me which version of the domain is actually being used at any one time. These are the different system domains that I have in my application. We're interested in this one, which is the workflow domain, and currently it's using the live version, the one that they just aren't finishing. So I want to replace it with my stub so that I can actually carry on development. So the way I do that in this particular example, I'll show you the code in a second, is to say, yes, domain workflow stub. Yeah, it's replaced it. And now I'm using the stub. So this is the code that I just showed you, this version here. So we have our document submitted method. This one is implemented because I implemented it. I was sick of waiting for them to do their thing. And what this does is just store the event in a list, creates some pre-canned data, and returns it. And that's all. So now I go back to my application. Before, I saw this list. This is what's actually in the database. If I refresh now, that's gone. All I'm seeing is pre-canned data, and yet my user interface works. So now I can go into my pre-canned data. Again, this works. I can submit it, and it works. I see no exception now. This has actually happened. How do I actually test it? Well, you'll notice in my code here, because I'm dealing with events that are kind of streaming in and out of the system, one of the cool things about those is that you can just store them because they're self-contained, and then potentially replay them at some point if you want to know what's happened. And so that's what's implemented. We can see document, event, stream. Oops. And so there we go. We have an event stream. This is just the objects, the actual event objects themselves, rendered to JSON. Nothing more complicated than that. And we can see all of the different things that we were doing. So we were loading the home page, loading a document. And this is the thing that we were interested in, this one here, where we actually submitted the document. And so we can see that, yes, I have now submitted this, and it worked. Now, the real punchline for this comes when I want to do functional testing using something like Selenium. I no longer need a database for that. I don't need my business logic to be implemented anymore. I'm testing something far, far thinner than my full stack application. Most people will write their Selenium tests as full stack tests. And I don't think you should. I think you should write them to test the user interface, which is not necessarily the entire stack. And we can do this. We have all the pieces here to do functional tests, UI tests, with the system in a half-finished state. So the piece of code to implement the submit is not ready. You've just seen it. It's got not implemented, written by some renegade. We could write a functional test using this. We can actually understand what the events going in and out of the workflow domain are, because we've switched to this kind of very declarative style. And actually, I've written one test, as you might have expected. So we're going to functional. Who's used Jeb? Jeb? So there are a few talks on, I think there were some talks on Jeb in the conference, weren't there? Jeb is brilliant. It's a way of driving Selenium. Who's used Spock? More people? Use Spock. If you're not using Spock, go and use it. It is awesome. So this is a very simple Spock test. As you can see, it's called it's called a specification rather than a test. And what it allows you to do is just to write highly structured unit tests, unit-style tests. So reading this through, this is the actual test itself. We're saying we want to make sure that we can load a document. So we're going to some page, which is, again, a Jeb page. This is instructing Selenium to open up a browser and direct it to this URL. You can then, using this page itself, like here. Interact with the page. These are the elements on the page that we saw before. So the title and the text that we're writing. And then pull data out. So this is actually loading data from the workflow and then making sure that it's displayed correctly. So what I want to do, because this is an event interchange, we want to go to the page, make sure the data's there, right, which is going to be our pre-canned data, and then make sure that the actual user interface domain sent the correct events into the workflow that we expect. And the way that we do that is to use I've got a little helper that just reaches out over HTTP and goes and gets the text. So if you can see that. There we go. This is the one it's going in. So this is using the fact that Groovy is just an awesome language to get a URL and just get the text from it. If you were to write this in Java, it would be like 4 or 5 lines. So nowhere near as clean. This just gets hold of a URL, gets the text from it, passes it into JSON so that you can use it in your test. And looking at my test, this is where I do that. So I go and get hold of the event stream that's been pushed into the workflow domain. The actual state, don't care. I couldn't care less about state. I'm writing a user interface, not a database. All I want to do is make sure that the data that's being displayed on the page is as I expect, which this does, and to make sure that the events that have gone into the workflow are also as I expect, which this does here. So this goes and gets the JSON that I showed you before and just tests it to make sure that the correct event is there and has got the correct data. So if I run this, just to prove that it might work, actually. So I will kill my server. That's going to run. It'll take a moment because it does. So what we should see in a second is a Firefox window appearing, exercising the page. You won't see it getting the actual event stream because that's done in the background via just normal Groovy code. But it will appear in a moment. It's coming, don't worry, I think. There it is. Yep. Damn it, too quick. Anyway, it passed. Is everyone okay with that? Yeah, I'll run it again, just because I want to see it. Where's it gone? OK, so we've actually done an effective test of just our application UI. Not the business logic, not the database, none of that. We don't care at this point. We have only tested this one section of the system. Now, this is actually quite interesting. It's kind of, I can exercise most of my code in the user interface via functional tests, and that would probably be OK. Most of the complaints that people have about using full-stack functional tests are normally about state management. We've removed that completely. So we could treat our Selenium tests as unit tests because they really are. They're testing our HTML and rendering. And our actual the rest of the UI code doesn't do that much. And so that kind of also speaks to one interesting thing, which is the fact that these domain boundaries that we've created, they actually work really well as test boundaries as well. So you can take an entire domain that we've cut up based on change, and what you'll find is in between the domains, there is going to be a very low level of coupling, and that's by you're actually deciding to do that. You want to do that because that allows them to change. Inside the domains, they'll be very highly coupled, very tightly coupled. That's what they call cohesive. And this, again, is what you want. And that means that you can test that in a big block as a big unit, and that's OK. That's fine. And that's what I've just done now. I've tested half a dozen classes, all in one test. And that's fine as far as I'm concerned. Unit tests don't mean methods. Right. OK, that's my code demo. Any questions on that before I flick back to the slides? Everyone all right? Awesome. Where's my settings? Ah, there it is. OK, so now that you've seen that, what next? Well, we have our system like this. This is what Larry down here calls a modular monolith. And this is where you cut your application up into pieces that can move independently or fairly independently. Once you've done that, you actually have explicit contracts between pieces of your code internally. You start to get some great options, which is the whole point. Is creating options for yourself. You can take these separate domains on my diagram and put them in Grails plugins. That works very well. Each of these can be its own separate plugin, built, tested independently, communicating with the others via some explicit contract. And that works nicely. So that's what we've implemented several times with large Grails applications. You also have the option, given that it's such a big thing now, to split into microservices. So this is our kind of bread and butter is understanding change in software. We like microservices a lot. For that reason, they give you options. More so than Grails plugins even, they allow you to change things. They allow you to adapt to change. There is a very significant cost with them, just like there is a significant cost in doing any of what I've described. And that is natural. You are buying yourself options that you can then realize at some point in the future. How much you want to invest in creating options is up to you. It really depends on how much change you predict happening. Microservices are effectively the ultimate in decomposition and creating contracts between pieces of code that are separate from each other. And so there is a higher cost in using them, but they set you up for change in possibly the best way that we've found so far. So yes, it's certainly possible. So a bit of blatant promo. If you have any trouble in changing your software and taking it forward, give me a call. I'm always happy to chat. I do like visiting the US, so say hi. If any of you are in London in November, we are helping to organize a conference called MuCon, which is a conference specifically around microservices. I think that it is pretty much sold out now, but they are investigating getting larger venues. We've kind of blown out the available venues that they normally use for conferences, which is very cool. So they're finding somewhere bigger. So if you are interested, go and sign up, and we might be able to get some more space if enough people sign up. If you do go, our drones will be in attendance. We tend to fly these little quadcopters around conferences. We're aiming to have a little fleet of them controlled by microservices as a way of demoing the idea. So yeah, it's a lot of fun. They're very funny things. So any questions? This is pretty much the end of the talk. I don't know how we did. Did we broach an hour? 1:15. Sorry? 1:15. 1:15? 50. Not quite then. OK, guys, questions?